Imagine this: red-hot metal, up to 33 feet long, being pushed with a dull roar into a massive rolling mill. No seams, no joints, just a perfectly smooth steel pipe appearing literally out of nowhere. These aren't scenes from a science fiction movie, but the daily work at one of the most unique factories in the world. How is it possible to create a pipe without a single seam? One that withstands pressure of hundreds of atmospheres and operates where other materials simply melt. Ready to walk through the scorching workshop and find out how true engineering perfection is born? Then let's embark on a journey to an amazing steel pipe factory. It all starts with cylindrical billets. Each one weighs 1 ton. That's like 3 smart cars in a metallic body. They are transported by rail or truck because other transports simply can't handle such a load. Each billet is secured on special pallets or in retaining clamps so it doesn't shift during movement. Upon arrival at the factory grounds, unloading is automated using cranes, manipulators, or hydraulic carts. The billets immediately go to the receiving area, where they are checked for compliance with technical specifications: chemical composition, shape, integrity. Before the hot steel becomes a pipe, it undergoes a truly dramatic inspection. Defects shall not pass. First, the billets get an X-ray. Well, not exactly X-ray, but something similar for metal: ultrasonic testing. You heard that right. The billet is coated with a conductive gel, like for a human ultrasound, and a transducer is moved across it. Special transducer ears shoot sound waves at a frequency of 5 megahertz. That's 100 times higher than submarine sonar. This is how they search for cracks and inclusions of foreign materials within the billets. The system builds a 3D map of defects with an accuracy of 1/100th of an inch. If it finds a saboteur, the billet is marked with red paint and sent to metal hell for remelting. Next comes the chemical analysis. For this, 5 or 10 metal samples are taken from each batch and sent to the factory laboratory. There, they use special spectrometers, devices that read the metal's composition using light emissions. The spectrometer determines over 12 elements in the composition in seconds. During the analysis, the sample is treated with an electric spark or a laser. This excites the atoms on the metal surface, causing them to emit light of different wavelengths. Each chemical element glows uniquely, so the device recognizes exactly which elements are present in the steel and in what quantities. How much carbon, manganese, chromium, nickel, or phosphorus. This analysis takes only a few minutes, but provides a complete picture of how well the billet meets technical requirements. If the composition isn't perfect, the batch might be rejected or redirected to other production lines. From 1 to 3% of billets are sent for remelting. Defective billets are sent to an electric furnace with a temperature of 2,900 degrees Fahrenheit, where the steel becomes liquid again. All the post-melting slag is used for road construction. 90% of defects are detected during the ultrasonic diagnostic stage. It's like finding a needle in a haystack in 10 seconds. The chemical analysis takes 17 seconds, faster than you order coffee at Starbucks. Quality control costs range from $50 to $100 per ton of steel, but it's better to overpay than to later have a well blowout due to low quality material. Quality control is the Karen's filter for steel. Only 97 to 99% of billets become pipes. The rest are sent for reincarnation. So when you hold coffee in a steel thermos, know this: its ancestors went through real metal special forces training. After checking the chemical composition, the cylindrical steel billets are delivered to the heating section, the place where a giant furnace stands. These furnaces are true giants, capable of holding over 1,000 billets simultaneously. To load the billets inside, massive automated cranes or special manipulators with heat shields are used. The billet is picked up using gripping mechanisms, large metal fingers or tongs that securely hold the heavy part. The crane carefully moves the billet to the open loading door of the furnace. At this time, the temperature inside can exceed 2,400 degrees Fahrenheit, so the entire process is maximally mechanized. People operate the machinery remotely from a safe cabin or control panel. The furnace has special guides or pushers that help place the billets carefully inside so that heat distributes evenly. After loading, the furnace doors are hermetically sealed and gradual heating to the working temperature begins. In 2 hours, the steel transforms into a plastic mass. The billet becomes ready for forming, like melted chocolate. Next, the monster drill comes into play. It weighs 12 tons. That's like 2 elephants. The red-hot steel billets, massive cylinders, are removed from the furnace and delivered to a special rolling machine, where one of the most crucial stages of seamless pipe production begins, creating the hole inside. The piercing process looks impressive. The red-hot billet is placed on a special support ring in front of the piercing mill, where a thick, cone-shaped rod awaits it, the so-called piercer point or piercing mandrel. At this moment, immense force is at work. The billet is rotated between 2 conical rolls, spinning in opposite directions. The rolls don't just squeeze the billet, they create strong rotational and axial pressure, causing the billet to stretch along its axis, flowing around the piercer point. To avoid cracks or ruptures, the pressure and temperature during piercing are controlled very carefully. If the billet cools too quickly, or the pressure is distributed unevenly, it can break or lose the required shape. Therefore, the process runs without interruption, and with strict adherence to all parameters. This process is called the Mannesmann method, named after the German engineers who invented it in 1885. After the initial piercing, the resulting rough pipe is called a hollow shell or bloom. The wall thickness of the shell is approximately 2 inches. It still has uneven walls and may contain small defects, so the next stage is rolling and calibration, where the pipe is stretched, straightened, and brought to the required dimensions and wall thickness. The red-hot steel billet enters under giant rolls 5 feet in diameter. Under tremendous pressure, it's drawn out into a slender pipe up to 40 feet long, faster than you can blink. This is where the major league of precision reigns. Wall thickness is reduced from 0.8 inches to 1.2 inches, with a deviation of less than 4/1000ths of an inch. That's thinner than a human hair. And all this happens at staggering speeds of 16 to 49 feet per second, faster than Usain Bolt on his best day. It's like rolling out the thinnest pizza dough. Only instead of dough, it's a red-hot steel core. And instead of a kitchen board, there's a shower of sparks and the roar of the rolls. Next, fire gives way to ice. Well, not ice, but cooling. The workshop heat is 122 degrees Fahrenheit, so workers wear special suits as if preparing to conquer Mars. Meanwhile, the pipes gradually cool in the open air. Their temperature slowly drops to 570 degrees Fahrenheit to avoid deformation and cracking. When the pipe emerges from the fiery dance of rolling, it resembles an enraged dragon, powerful, but bent into wild spirals. That's when the 8-roll giant enters the scene, a mechanical Hephaestus that will forge perfect forms. Its rolls, stronger than the rocks of Olympus, bend the steel with a force of 500 tons. That's like putting 250 Land Rovers on the pipe. But this force isn't a destroyer, but a surgeon. It corrects curvatures smaller than the thickness of a hair. And then comes the time for lasers. They scan every millimeter, finding the smallest defects, invisible cracks, minor unevenness. And when they find something, plasma scalpels enter the game. 10 times hotter than lava, they cut the metal like cosmic lightning bolts. All that remains of the defects is smoke and legend. If the Colossus of Rhodes were made of such pipes, it would still be standing today. Imagine every tire on your car as the result of decades of innovation, research, and fine-tuned manufacturing. Goodyear, one of the giants in this industry, produces tires that are engineering marvels. But how exactly are these technological masterpieces made? Let's break it down, step by step, and get a sense of the scale of this incredible work. Goodyear was founded back in 1898 and named after Charles Goodyear, the inventor of vulcanized rubber. The production of Goodyear tires begins with carefully selected raw materials. The key ingredient, of course, is rubber. But not just any rubber you'd find in a forest. This is a complex material made from natural rubber and synthetic substitutes. Natural rubber is harvested from the sap of hevea trees grown in tropical regions. This sap is called latex, a familiar term, right? The main suppliers of natural rubber are countries in Southeast Asia, like Thailand, Indonesia, Vietnam, and Malaysia. To collect the sap, neat cuts are made on the bark of hevea trees, similar to how maple syrup is gathered. Latex slowly oozes out and is collected in small containers attached to the tree trunk. A single tree produces only a small amount of latex daily, so plantations are packed with thousands of trees. Initially, latex has a liquid consistency and needs processing. Acids are added to it, causing the latex to coagulate into an elastic mass. Typically, formic acid is used. Yes, formic acid. Sounds surprising, doesn't it? The name dates back to the 1700s, when scientists first extracted this acid from ants. Back then, chemists boiled ants and discovered a liquid with peculiar properties. It turned out to be an acid that many insects, including ants and bees, use as a natural defense mechanism. Today, no one harvests formic acid from ants anymore. Instead, it's synthesized on an industrial scale from chemicals like methanol or carbon monoxide using modern technology. This method is way more efficient than collecting it from insects. Formic acid works perfectly for latex processing because it's non-toxic in small amounts. It easily coagulates the protein molecules in latex, turning the liquid into a solid elastic mass. Plus, it dissolves in water, making it easy to wash away any residue after treatment. After adding the acid, the resulting material is pressed into blocks or rolls and dried. This process significantly reduces its volume for easier transportation. The dried rubber is shipped to factories worldwide. For Goodyear, this includes plants in the United States, Germany, China, and other countries. The rubber is transported by sea in large bales that are easy to store and use in tire production. This covers natural rubber, but how do they make the synthetic kind for tires? Synthetic rubber is an artificially created material made from petroleum products. Its main component is butadiene, a chemical derived from gases left over after refining oil or natural gas. Butadiene, along with other chemicals like styrene, undergoes a process called polymerization. This chemical reaction links molecules into long chains, creating a material with high elasticity. The most common types of synthetic rubber are styrene butadiene rubber and polybutadiene rubber. To give synthetic rubber the properties needed for tires, such as strength, wear resistance, and temperature resilience, special additives are mixed in, like carbon black or silica, and plasticizers. Synthetic rubber is produced on a large industrial scale and shipped to factories in the form of granules, rolls, or preformed blocks. At Goodyear's factories, a rubber compound is created by combining the best qualities of both natural and synthetic rubbers. The rubbers are weighed precisely according to formulas tailored to specific tire models. In massive industrial mixers, the rubbers are blended with other ingredients: carbon black, silica, sulfur, oils, and chemical additives. Think of it like making dough, but under high pressure and heat. During mixing, the rubber turns into a thick black paste. This stage is crucial because it defines the tire's future characteristics: grip, durability, and temperature resistance. The mixture is repeatedly needed to ensure all components are evenly distributed. This guarantees uniformity in the final rubber. After mixing, the material is cooled and formed into large sheets, which are then cut into pieces for further tire production. The process of cutting rubber sheets at the factory is truly impressive in scale. This isn't done with kitchen knives, but with massive industrial machines that work with the precision of jewelers, but on a factory-wide scale. The thickness of the rubber sheets varies depending on the part of the tire they're meant for. For example, the layers for the tread are thicker than those for the sidewalls. Before cutting, each roll or sheet passes through an automated inspection system. Machines check for defects like air bubbles, tears, or uneven thickness. Anything that doesn't meet standards is immediately discarded. Cutting is done using specialized high-tech machines. Rotary knives, resembling spinning discs, effortlessly slice through the rubber, creating perfectly straight strips. Lasers, the most advanced technology, can cut rubber without physical contact, ensuring extraordinary precision. The laser beam literally melts the material at the desired spot, leaving a flawlessly smooth edge. Depending on the production stage, sheets may be cut into long, narrow strips for tire reinforcement or left in large pieces for the tread. Everything is programmed, and parameters are automatically adjusted based on the type of tire being made. After cutting, materials are sorted by type and size. Strips are rolled up, and sheets are stacked. All of this is transported to the next department for tire assembly. Each machine processes thousands of feet of rubber daily. Powerful engines roar, knives spin at incredible speeds, and workers monitor everything through computers. This conveyor never stops, producing hundreds of tires every hour. It's like surgery on an industrial scale. Everything must be flawlessly precise to ensure the finished tire is safe and high quality. Goodyear is one of the world's leading tire manufacturers, with production facilities in 22 countries and 52 factories. Let's circle back to another fascinating aspect of this story: the ingredients beyond rubber. Why are they added? Carbon black gives the tire strength and protection against UV rays. Silica improves road grip, especially in wet conditions. Sulfur and other chemicals help rubber retain its shape and elasticity under different conditions. As you can see, every detail matters. But that's not all. Let me tell you about the skeleton of the tire. You know it's not just rubber, right? The core consists of a multi-layered structure. The quality of this framework determines the tire's strength, durability, and ability to support the weight of the vehicle. This process involves several sequential and high-tech operations. But first, let's look at the materials. Textile cords are a must in the tire's construction. These are threads made of polyester, nylon, or even aramid, a highly durable synthetic fiber. They provide flexibility and lightness. Steel cords are also added. These are thin yet incredibly strong metal wires that give the framework rigidity and the ability to withstand heavy loads. Rubber acts as the bonding material between the layers of cord, creating a strong yet elastic structure. Cords pass through specialized machines that evenly coat them with rubber. This binds the fibers together, protects the textile or metal from moisture and corrosion, and ensures a strong bond with other rubber layers during vulcanization. This process is incredibly precise. If the rubber layer is too thick or too thin, it could compromise the tire's safety. Next comes the breaker. This part of the framework lies between the tread and the tire's core. Its job is to distribute the load across the tire and protect it from punctures. The breaker is made of multiple layers of steel cord laid at specific angles. Each layer is cut to a template and laid out in a precise sequence on specialized drums. The angles are computer-controlled to achieve the desired characteristics. The main framework is assembled on a special building drum that rotates, allowing all layers to be evenly laid out. First, textile layers are added for flexibility. Then, metal wire rings are added to form rigid sidewalls. These rings help the tire stay firmly on the rim. The tire bead, its inner edge that contacts the wheel, must be extremely strong. The bead ring is made from multi-layered steel strips coated in rubber. Side layers of rubber are added to the main framework to protect the tire from damage. This entire sandwich is secured on the drum using pressure and heat. Imagine this. Every minute, over 70,000 Oreo cookies are sold worldwide. That's enough to circle the Earth more than 400 times. But what makes them so insanely popular? How do they create that legendary flavor and perfect texture, loved in over 100 countries? Today, we're stepping behind the scenes at one of the world's most famous factories to uncover all the secrets behind this iconic cookie. From its unique design to the creamy filling, let's dive in. The Oreo recipe was first created back in 1912 at a factory in Manhattan. To this day, it remains the most popular cookie in the world. Since its inception, more than 500 billion Oreos have been sold. If you lined them all up, they'd wrap around the Earth over 400 times. Oreo is also one of the most active brands on social media, with over 40 million followers on Facebook and millions of fans on TikTok and Instagram. Campaigns like Twist, Lick, Dunk have gone viral in countless countries. It all begins with high-quality ingredients. Oreo uses premium-grade flour, cocoa powder, sugar, vegetable oils, and a secret blend of flavorings that make every batch unmistakable. But let's face it, ingredients alone aren't magic. They're mixed in precise proportions to form the base for the cookies. Inside the factory, massive mixers, capable of handling hundreds of pounds of dough at a time, work like a culinary orchestra, fast yet precise. Here's where the first secret lies: the cocoa. Oreo uses a specially processed cocoa powder that gives the cookies their rich, deep black color. And no, that shade isn't just from the chocolate, it's the result of a meticulously fine-tuned chemical process. Once the dough is ready, it's time to shape the cookies. This is where a high-tech conveyor system with custom molds steps into action. Yep, every Oreo cookie features a unique pattern, and it's not just for decoration. Each cookie's design is perfectly symmetrical, with 12 flowers, 12 dots, and 90 ridges around the edge. This iconic design hasn't changed since 1952, the year of its one and only redesign. The texture plays a big role in the overall taste experience. The smooth edges hold the cream in place, while the tiny, puzzle-like details add that signature crunch. Here's a fun fact. The machine that stamps the cookies can churn out up to 3,000 pieces per minute. Imagine that pace. Every single detail has to be flawless. Baking Oreos is a true science. The dough travels through an oven line that stretches up to 245 feet long, with the temperature monitored literally at every inch. First, a high temperature helps the cookie hold its shape, and then it's gradually reduced to prevent overdrying. The result? That perfect balance of a tender texture that melts in your mouth while staying satisfyingly crunchy with every bite. Now, let's move on to the filling. The cream for Oreos is made separately, and this process? It's nothing short of modern-day alchemy. Massive mixers whip the cream filling to the perfect consistency you know and love. Here's a little secret. The cream isn't just spread on, it's piped through special rotating nozzles to ensure an even layer. For the classic Oreo, that's a vanilla cream filling. But you already know how many flavors are out there today, right? From strawberry to mint chocolate, each new flavor undergoes rigorous testing before hitting store shelves. The formula for Oreo's cream filling is top secret, with only a handful of people in the world knowing the exact recipe. Now comes the most magical part, joining the two cookie halves. This process, called sandwiching, is performed with incredible precision by machines. Fun fact, every other cookie half is flipped upside down to ensure a smooth connection with the cream. And just like that, in seconds, the iconic sandwich is born, ready to enjoy. Studies show that around 50% of people twist apart their Oreos before eating them. Even more folks dip them in milk. In fact, Oreo is officially considered the perfect cookie for milk. Scientists have even experimented to find the optimal dunk time, 4 seconds. That's just long enough for the cookie to maintain its crunch while melting in your mouth. Every hour, over 1.5 million Oreos are produced in factories worldwide. Once the cookies are ready, they're sorted and sent to the packaging line. Quality checks happen every single time. And yes, there are imperfect cookies. They're sorted out and sent for recycling. Curious how Oreo stays so fresh in its packaging? It's all thanks to vacuum sealing. The packaging is specifically designed to preserve texture and flavor. It's made of multi-layered materials that keep out moisture and air, ensuring the cookies stay crispy. The outer layer of polypropylene provides durability, while the inner layer creates a barrier to protect against oxidation. The key to Oreo's packaging is the vacuum seal. Once the cookies are packed, excess air is removed from inside the bag to eliminate contact with oxygen. This keeps the cookies fresh for up to 9 months, or even longer. Each package is precisely cut to size using high-precision lasers, guaranteeing an airtight seal. You've probably noticed how easy it is to open modern Oreo packages. That's thanks to the peel and reseal closure, which allows you to open and close the package multiple times. This way, the cookies stay fresh even after the first opening. Oreo offers a wide range of packaging options so everyone can find their perfect fit. Standard packs, a classic for the home. Mini Oreos, small, snack-sized packs perfect for on-the-go munching. Mega packs, ideal for those who just can't get enough. And let's not forget individual packs of 2 or 3 cookies. Super convenient for the office or a lunchbox. That iconic blue packaging? It's no accident. The color is associated with freshness, lightness, and happy emotions. Each pack features a photo of the cookie with milk, sparking instant cravings. In some countries, Oreo even includes interactive packaging with QR codes, leading to games, recipes, or videos, adding an extra layer of fun. Recently, Oreo has been working hard to make its packaging more eco-friendly. In 2023, the company began testing recyclable materials for its packs, aiming to reduce the carbon footprint of production. In some countries, fully recyclable packaging is already in use. After packaging, the packs go through special scanners to check for weight and airtight seals. If even the smallest defect is found, the package is pulled from the line. Oreo uses specialized refrigerated containers during transportation to prevent temperature fluctuations. This ensures the filling's texture and the cookie's crunchiness are perfectly preserved. Did you know Oreo is made in over 50 countries and sold in more than 100? Every day, more than 40 million cookies are produced. That's more than the population of some countries. Interestingly, recipes and flavors can vary by region. For example, green tea flavor is a hit in China, while caramel fillings are a favorite in Latin America. Oreo has even been to space. In 2021, the brand sent its cookies to the International Space Station as part of a promotional campaign. And back in 1992, musician Weird Al Yankovic released a song called The White Stuff, a parody of New Kids on the Block's The Right Stuff. The song? A hilarious ode to the creamy filling of Oreo cookies. One of the most creative and fun marketing initiatives by Oreo is the Oreo Stacking Championship. The rules are simple. Participants compete to see who can build the tallest tower of Oreo cookies before it topples. But like everything Oreo touches, this competition transforms into a full-blown event, complete with heroes, records, and even a little drama. The current world record for stacking Oreo cookies stands at 54 cookies in a single tower. This record was set back in 2018 by an American at a local festival in Texas. Typically, records in these competitions range between 30 and 50 cookies because each additional layer makes balancing the structure even harder. Thanks to the cookie's round shape, towers often collapse at the most nerve-wracking moment, when someone tries to add that final cookie. It's all in good fun though, and the laughter from the audience and participants is infectious. At one championship in Japan, the winner was an 85-year-old grandma. She credited her victory to age bringing calm and patience. Oreo is officially recognized as the most popular cookie in the world, outselling all competitors in the cookie and dessert category. What makes Oreo so special? It's not just the flavor and texture, it's the emotions they spark. Admit it, you twist the cookie apart before eating it, right? Or maybe you dip it in milk. In the US, there's a cult-followed ritual for eating Oreos. Twist, lick, dunk. The process involves separating the cookie, licking off the cream, and dunking the rest in milk. Interestingly, women are more likely than men to take their Oreos apart before eating. It's this simplicity and versatility that have made Oreo a favorite for millions. It's a cookie that brings people together because everyone finds their own way to enjoy it. Coca-Cola's annual sales exceed $47 billion, which translates to more than 1.9 billion bottles consumed every day. To meet this huge demand, the company operates over 900 bottling plants worldwide. But how exactly is this refreshing, fizzy drink made? To uncover the secret ingredient added to Coca-Cola, we will embark on a journey across the United States and dive into the atmosphere of one of Coca-Cola's massive production facilities in the country. The mysterious formula that defines Coca-Cola's flavor is carefully kept secret. Some say it is stored in one of the most secure vaults on the planet, and only a select few have access to this culinary secret. However, It is known that the drink contains a blend of natural flavors, including vanilla, cinnamon, and citrus. This precise combination of aromas gives Coca-Cola its signature taste, setting it apart from other sodas. The production of Coca-Cola is a detailed and complex process that ensures consistency and perfection in every bottle of this iconic drink. At the beginning of the process, the components are combined. A precise mixture of high fructose corn syrup, caramel coloring, caffeine, and phosphoric acid is blended in exact proportions to create a syrup with 50% sugar content. The syrup is then poured into massive mixing tanks, holding 5,000 gallons, where it is combined with water at a ratio of 1:5. At this stage, the mixture is continuously stirred to ensure the perfect integration of all ingredients. The next stage of the process is carbonation, where carbon dioxide is added to the mixture to create Coca-Cola's signature bubbles. This process is carefully controlled to ensure the same level of carbonation at all production facilities. To achieve this, the water is chilled to just above freezing, and carbon dioxide is pumped in under high pressure, allowing it to dissolve more quickly. Once the liquid has absorbed enough carbon dioxide, it is bottled and sealed tightly. When you pop open a fizzy Coca-Cola, the carbon dioxide under pressure is released, forming bubbles and creating the iconic fizz. Next, we enter the section dedicated to packaging the product. Here, plastic bottles are formed by blowing preforms into their final shape, before being filled with the carbonated mixture. At this stage, each bottle is carefully inspected by a machine to ensure that the amount of liquid is correct, and the caps are sealed properly. Bottles that do not meet the standards are removed from the production line. Speed and efficiency define the Coca-Cola bottling and capping process. As bottles are neatly placed onto a conveyor belt, they are then sealed and the product is labeled. Before distribution, each bottle is stamped with the production date and batch code, either on the cap or the side of the container, ensuring all necessary information is visible. The drink is also packaged in cans and glass containers, with multiple production lines operating simultaneously. Glass bottles are primarily reused, undergoing a thorough cleaning process using chemicals and high-pressure water, fully restoring them. However, brand new bottles are also produced. Coca-Cola follows a recycling strategy, continually encouraging the use of reusable packaging. Quality control is crucial in Coca-Cola's production process. The company implements strict measures to ensure that every bottle meets high-quality standards. Tests are conducted at various stages of production to guarantee the product's consistency and quality. These tests include tasting the mixture to verify its flavor, carbonation, and appearance. Additionally, bottles are tested under pressure to ensure they can withstand carbonation. Beyond these checks, Coca-Cola follows rigorous sanitation and safety procedures. To protect both workers and the product's integrity, employees wear protective clothing and ensure that the production facilities remain clean and free from contamination. The production of Coca-Cola is a complex and carefully controlled process that ensures consistency and quality in every package. After passing quality control, the products undergo a thorough wash with powerful jets of water before being packed for shipment. Cans and bottles are arranged into compact forms or stored in containers. With pinpoint accuracy, mechanical arms expertly position the blocks in place to create large pallets. The blocks are then moved to the packing area, where they are neatly arranged and carefully wrapped to ensure smooth transportation. The finished product is shipped to stores and distributors all over the world, making Coca-Cola available everywhere. The production process of Coca-Cola can vary slightly depending on the region, as customer preferences may differ. To cater to these preferences, Coca-Cola adjusts its recipe to align with local tastes, ensuring that every customer enjoys the flavor they love most. However, the core ingredients remain unchanged, carefully selected and blended to give the drink its signature taste. In the early stages of production, these elements are combined in precise proportions to create the liquid that gives Coca-Cola its unique and unmistakable flavor. High fructose corn syrup, derived from cornstarch, is used as a sweetener in many carbonated beverages. Coca-Cola's distinctive dark brown color comes from caramel coloring, which is achieved by heating sugar to the point of caramelization. Each year, more than 660 million pounds of sugar and other sweeteners are used to meet global demand for the beverage. Caffeine is included to give a boost of energy, while phosphoric acid adds a subtle tartness that balances the sweetness of the high fructose corn syrup. A crucial component of large-scale Coca-Cola production is water. Each processing plant requires a significant amount of water to meet production needs. In Mexico alone, Coca-Cola uses more than 14.5 billion gallons of water annually to maintain operations. The combination of these elements creates a delightful experience that has made Coca-Cola a legendary global drink. What actions do you think Coca-Cola has taken to reduce its environmental impact? Recently, Coca-Cola has been implementing innovative, plastic-free packaging alternatives to conserve resources and reduce waste. In 2023, the company introduced the Light Pack Top, an original holder made from recyclable cardboard designed to store bottles and cans. This replaced traditional plastic packaging and helped reduce the company's plastic use by 220 short tons per year. Coca-Cola is also committed to promoting the recycling of plastic and aluminum packaging. Recycling signs and information are placed on plastic containers and street bins to raise awareness about waste separation. At recycling plants, used plastic bottles are collected, inspected, sorted, and transformed into new products. A large industrial machine grinds the bottles into small pieces, which are then cleaned and go through a complex compression process, turning them into fresh plastic containers for food. Coca-Cola has recently updated its product lineup to include healthier and more eco-friendly alternatives, with a focus on low-sugar beverages and social responsibility initiatives. The company has launched environmental projects, such as optimizing water usage and creating recyclable packaging. Today, Coca-Cola is one of the most well-known brands globally, present in over 200 countries, and offering a diverse range of products that cater to a wide variety of consumer preferences. Over 28 million short tons of olives are harvested every year, each one playing a role in the creation of olive oil, liquid gold. From ancient traditions to cutting-edge technology, this video will reveal the secrets behind producing the oil that has shaped civilizations. I visited one of the world's leading factories to bring you this story. At modern industrial facilities, collaboration with agricultural producers is essential. Experts study the ripeness of the olives to determine the perfect time for harvest. There are two main methods for doing this. In some regions, they still use traditional techniques where workers gently strike the branches with sticks, so the olives fall into nets spread out on the ground. However, on large farms, you'll often see vibrating machines that shake the trunks, causing the olives to drop into upside-down containers positioned around the tree. Once the olives are harvested, they are quickly transported to the mill for further processing. Speed is crucial since olives begin to spoil immediately after being picked. Ideally, no more than a day should pass between harvesting and processing. When the trucks arrive at the plant, they unload the olives into large receiving bins. This is where the quality control stage begins, with samples taken to assess the condition of the olives, their ripeness, and to check for any defects or diseases. The olives then go through a cleaning process to remove leaves, branches, stones, and other unwanted materials. Ventilation systems and vibrating screens are used to effectively separate these elements. After dry cleaning, the olives are rinsed in cold water to remove any dust, dirt, or impurities that could affect the quality of the oil. Crushing is the process of breaking down the olives to extract the oil contained in their cells. In modern mills, this is done using hammer mills or metal discs that rotate at high speeds. The crushed mixture includes not only oil, but also the plant liquid from the olives, along with solid pieces of pulp and pits. This mixture, known as olive paste, is the primary substance used to produce oil. The paste is then transferred to malaxes, where it is gently mixed to break the emulsion of water and oil, making the separation process easier. Mixing occurs at a precise temperature, typically between 80 and 84 degrees Fahrenheit. There are two main methods for extracting the oil. the traditional pressing method, and continuous centrifugation. The traditional method, although less common, involves pressing the olive paste using fibrous discs called mats. In the continuous centrifugation method, the difference in density between the oil, water, and solid particles is used. The paste is placed in a high-speed horizontal decanter, which spins rapidly, separating the components. The oil extracted through centrifugation contains tiny suspended particles and traces of water. To remove these, a natural separation process takes place in stainless steel tanks. Many industrial facilities also use vertical centrifuges to more efficiently separate the smallest water particles and remaining solids. Packaging is done on automated lines that quickly fill, seal, and label bottles or cans. To protect the oil from light, it's best to use opaque or tinted materials, such as dark glass or cans. During bottling, strict quality control is carried out to ensure accurate weight, proper sealing of caps, and correct labeling, as well as to detect any potential defects. Throughout the entire process, physical, chemical, and sensory quality checks are performed to determine the final grade of the oil. Olive oils are divided into three categories: extra virgin olive oil, which is of the highest quality with an acidity level below 0.8% and no sensory defects; virgin olive oil, characterized by good quality with a maximum acidity of 2% and minor sensory defects; and lampant olive oil, which is not suitable for direct consumption and requires refining. Around 6,000 years ago, in the Middle Eastern region, the first evidence of olive oil production was discovered. In the lands that are now part of Syria, Lebanon, and Israel, early agricultural pioneers recognized the potential of this unique fruit. Initially, the process was simple but labor-intensive. Olives were crushed with stones, and the oil was then separated through decanting. Before long, this precious golden nectar became a highly sought-after commodity, not just for its nutritional value, but also for its healing and ceremonial properties. The Phoenicians, skilled in maritime trade, were responsible for spreading the olive tree and its valuable oil throughout the Mediterranean, sailing from port to port and coast to coast. The olive tree took root in unfamiliar lands. In ancient Greece, the olive tree gained an almost legendary status. According to tradition, the goddess Athena gifted this miraculous tree to the city of Athens. In ancient Greece, athletes who won the Olympic Games were honored with olive wreaths, and soldiers were given ointment made from the same tree to prepare them for battle. The Romans, heavily influenced by Greek culture, took olive cultivation to a higher level. They developed innovative methods for growing and harvesting olives, and expanded olive groves across their vast empire. In the Roman world, olive oil became a staple fat, symbolizing the sophistication and refinement of Roman culture. Beyond its culinary uses, olive oil was revered for its healing properties. Hippocrates, known as the father of medicine, prescribed it for a variety of ailments. In earlier times in Rome, Galen, a physician famous for treating gladiators and emperors, incorporated olive oil into his medicinal ointments. Before the discovery of oil, olive oil played a crucial role as a source of light. For many years, oil lamps illuminated homes, religious buildings, and reading rooms, literally fueling the light of knowledge and culture. During medieval times, monasteries were responsible for preserving the ancient tradition of tending to olive groves and producing oil. In their fields and manuscripts, they cared for olive trees and refined cultivation techniques. When the New World was discovered, the olive tree journeyed across the seas. Adventurers from Spain and Portugal brought olive tree cuttings to the Americas, planting the first olive groves in Mexico, Peru, Chile, and California. Olive oil, especially extra virgin, is rich in beneficial nutrients like monounsaturated fats and antioxidants, which help support heart health by lowering harmful cholesterol levels and reducing inflammation in the body. Research shows that regular consumption of olive oil can reduce the risk of cardiovascular diseases and strokes by improving circulation and helping to maintain healthy blood pressure. It also has a positive effect on digestion, promoting better absorption of nutrients and preventing stomach issues. And finally, we'd like to share a few lesser-known facts about olives and olive oil. The oldest olive press was discovered on the island of Crete and dates back more than 3,500 years. It was so advanced that it used principles similar to modern methods. Olive oil doesn't spoil as quickly as many believe. When stored properly in a cool, dark place, it can retain its properties for up to 2 years. Olives of different colors aren't different varieties. Green and black olives are the same fruit. Green ones are harvested earlier, while black olives are left on the tree to ripen longer. Did you know that a banana isn't actually a fruit from a tree, but rather a type of giant grass? And a single bunch can weigh up to 110 pounds? From tropical plantations to your table, join us as we uncover the amazing secrets behind the banana's journey and learn about the technologies that make it all possible. In the world of fruits, there is one true king, essential to breakfast, dessert, or any afternoon snack. This fruit is not only delicious, but also incredibly nutritious, with a history that goes back centuries. Yes, you guessed it, we are talking about bananas. But do you know where they come from and the journey they take from seedling to your plate? I traveled to the tropical regions where bananas are grown, ranging from Latin America to Southeast Asia. Each region has its own unique methods and traditions for cultivating these green treasures. Today, I'm excited to share with you the fascinating process behind it all. Sunrise on a banana plantation marks the start of another hardworking day. Here, among endless rows of greenery, begins the story of every banana that will eventually make its way to your table. Bananas aren't trees in the traditional sense of the word. They are the largest herbaceous plants, producing fruit in bunches that can weigh up to 110 pounds. Growing such a marvel of nature requires not only knowledge and experience, but also incredible care and attention. Caring for banana plants starts with planting seedlings and continues all the way through to harvest. Farmers regularly inspect the plants for pests and diseases, ensuring they receive the right amount of water and nutrients. Modern technology plays a key role in banana cultivation. From drip irrigation systems to drones used for monitoring plant health, these innovations help increase yields while reducing the environmental impact. It all begins in the fields, where the meticulous work of planting banana seedlings and preparing the soil takes place. I watched as farmers used cultivators to carefully place the seeds in the optimal spots and gently watered the seedlings with a fine mist or spray. The maturation period for banana plants can range from 9 to 20 months, although some varieties develop faster than others. As the plants mature, special agricultural techniques are applied. For instance, farmers trim the tip of the banana bud to stimulate the development of the bunch. To speed up the formation of banana clusters, they also remove some of the female flowers. Over time, these clusters grow into mature bananas. At this stage, disease management becomes crucial. Common banana leaf diseases, such as Xanthomonas wilt, Fusarium wilt, and black or yellow sigatoka, are combated by removing infected leaves and using pesticides. These treatments are essential to protect banana crops from pests and ensure a healthy harvest. Harvesting bananas is truly an art that requires precise timing based on visual cues, such as the size and ripeness of the banana. During this time, workers also monitor the growth of pups, young banana plants that sprout from the roots of older plants, to ensure they stay healthy. I watched as workers carefully cut each bunch from the vine, taking great care not to damage the fruit. Once the bananas are harvested, they are sent to processing areas. The bunches are tied together and transported via a conveyor system to a washing station. During the washing process, bananas are cleaned of harmful bacteria and debris to prepare them for further processing. For transport, they are protected by cotton paper, which is placed between each row of bananas to keep them safe during their journey. Bananas are highly perishable, so quick preparation is essential. When I arrived at the banana processing plant, I was shown the entire preparation process. First, the bananas are rinsed with water, measured, and the protective cotton paper is removed. Before they are packaged, the bananas are cut into smaller bunches and washed one last time to ensure they are completely clean. Workers then use scissors to cut the bunches into sections, check the weight, and prepare them for distribution before moving them to the packaging line. This precise procedure highlights the level of care and attention required to ensure bananas remain fresh and high quality throughout their journey from the field to the consumer. The transportation and storage of bananas is a complex process that requires close monitoring at every step. After harvest, the bananas are carefully packed into boxes to prevent damage. They are then transported in special temperature-controlled containers to avoid premature ripening. During transportation, often by sea, the bananas are kept at an optimal temperature of around 55 degrees Fahrenheit. Upon arrival at their destination, bananas go through a ripening process in specially equipped chambers. Here, the temperature and ethylene concentration are carefully controlled to ensure the bananas ripen evenly before they reach store shelves. This process allows the bananas to develop their characteristic yellow color and desired softness. In stores and markets, bananas are kept at room temperature, away from direct sunlight and ethylene-producing products to minimize further ripening and extend their shelf life. This helps ensure that the bananas remain fresh and flavorful until they reach the consumer. At the same time, there is a dedicated section of the factory for producing banana chips. Banana chips are a tasty and popular snack made by drying or frying thinly sliced pieces of banana. They can be made from either ripe or unripe bananas, depending on the desired flavor and texture. I watched as bananas were peeled by hand to remove the fruit. Banana chips, made from either mashed or sliced bananas, are fried in hot oil and turn out incredibly delicious. Once the chips are fully cooked, they are placed on a draining tray to remove excess oil, ensuring they have a perfectly crispy coating. The dried chips are seasoned with spices to make them even more flavorful. The factory staff carefully plan each step before sending the chips to the packaging area, which is managed by an artificial intelligence-powered machine. Before placing the chips into plastic bags, the machine takes precise weight measurements. Once the workers finish filling the bags, they place them into paper containers and seal them with the company's branding. These containers display important information, including the serial number, production date, and expiration date. The containers are then securely sealed with tape, ensuring the chips are safe for transport and storage. This comprehensive process, starting from banana cultivation and ending with banana chips and market-ready packaging, highlights the significant effort and technology involved in preparing these products for sale or export. It offers an interesting glimpse into the banana processing industry, showcasing the intricate procedures used to preserve the freshness and high quality of bananas from harvest to final sale. Banana chips are a source of nutrients like potassium, B vitamins, some dietary fiber, and minerals, especially when they are dried. However, fried banana chips can contain a considerable amount of fats and calories, so they should be eaten in moderation. You can also make banana chips at home, where you can control the amount of oil and seasoning added, making them a healthier option compared to store-bought varieties. The next time you grab a banana, take a moment to think about all the effort that went into its cultivation, harvest, and delivery. Remember that each bite connects you to distant countries, cultures, and people who make this world so vibrant and diverse. Heinz is a brand that has conquered the world. Just imagine. 11 billion bottles of ketchup are sold every year, and every second bottle in the United States is a Heinz. But what is this ketchup really made of? What drives such incredible success? And what secrets are hidden in every drop? Keep reading to uncover all the mysteries behind this iconic sauce. The main ingredient in Heinz ketchup is tomatoes. The production process starts with the careful selection of raw materials, where Heinz applies strict standards for choosing ingredients. Heinz uses special varieties of tomatoes grown exclusively for making ketchup. These tomatoes have a high content of natural sugars and acids, which gives the product its unique flavor. The tomatoes are cultivated on certified farms that follow strict environmental standards. By the way, did you know that the first ketchup recipe, which came from Asia, wasn't made from tomatoes? The recipe has completely transformed over time, allowing us to enjoy the wonderful sauce we have today. So, let me continue. Before purchasing the tomatoes, each batch undergoes laboratory testing to check for nutrients, acidity levels, and compliance with safety standards. Only the best tomatoes are used to make Heinz ketchup. In addition to tomatoes, other ingredients like sugar, vinegar, salt, spices, and natural flavorings are used in the recipe. All of these components are also rigorously tested to ensure they meet quality standards. Once the tomatoes are selected, they are transported to the factory for initial processing. At this stage, the tomatoes undergo thorough preparation before further refinement. First, they arrive at an automated line where they are washed using water sprays. This process takes place on a conveyor belt, allowing a continuous flow of tomatoes to be cleaned. Highly efficient water systems are used to remove dirt and dust from each tomato. On the conveyor belt, the tomatoes are sorted by quality and size. Optical sensors are employed to automatically reject any tomatoes that do not meet the standards. Any defective tomatoes are either sent for reprocessing or disposed of. The remaining tomatoes go through machines that peel off the skin. This often involves a process called thermal treatment, blanching, where the tomatoes are briefly heated to make the skins easy to remove. After peeling, the tomatoes are ground into a puree. This is done with special grinding machines that break down the flesh into small particles. The tomatoes are transformed into a smooth mass, which will later be used to make ketchup. Interestingly, until the 1990s, ketchup was mainly used as an ingredient in cooking. People baked pies, fish, and meat with it. It wasn't until the introduction of hamburgers, hot dogs, and French fries that ketchup became a standalone sauce. So we can thank the Germans and Belgians for inventing those foods. At this stage, the tomato puree is blended with other ingredients to make Heinz ketchup according to its classic recipe. The preparation process also involves automated systems that ensure continuous production. Into the pre-prepared tomato puree, other ingredients like sugar, salt, vinegar, and spices are added. The dosing process is handled by automatic dispensers, which precisely measure the amount of each ingredient to achieve the perfect flavor. Once all the ingredients are added, the puree is transferred to large mixers. Here, the mixture is thoroughly blended until it reaches a smooth, uniform consistency. The mixing machines are equipped with blades that rotate at high speeds, ensuring the ingredients are evenly incorporated. To ensure a long shelf life and eliminate harmful microorganisms, the mixture goes through a pasteurization process. The ketchup is heated to high temperatures, usually around 194 to 203 degrees Fahrenheit, which helps preserve its freshness without the need for artificial preservatives. This process is controlled by automated systems that maintain the exact temperature and processing time needed. Conveyor systems play a crucial role in ensuring the seamless production process at Heinz factories. Here's how the conveyor system works across different stages of ketchup production. One of the most important steps is the transportation of raw materials. All ingredients, tomato puree, sugar, vinegar, and other components, are moved along conveyor lines to the mixing stations. This helps maintain precise dosing and speeds up the process. After the ketchup is prepared, it is transported via conveyors to the packaging department. But before I dive into the packaging process, here's an interesting tip. Did you know you can clean and polish metal items with ketchup? Its ingredients make it an eco-friendly and natural cleaning solution. Simply rub ketchup onto your pots, let it sit for about 10 minutes, then rinse it off with clean running water. I keep meaning to try this hack myself, but I always end up eating the ketchup before I get the chance. Now, back to packaging. It's a fully automated process that involves several steps: filling the bottles, capping, and labeling. Let me break them down for you in more detail. Bottle filling. The ketchup is poured into pre-prepared, sterilized bottles. Automated machines precisely control the amount of ketchup in each bottle, preventing both overfilling and underfilling. Fun fact: a ketchup fan once set a world record by drinking an entire bottle in just 32.27 seconds. Capping. After the bottles are filled, they are automatically sealed with caps. Automated capping machines ensure each bottle is tightly and securely closed. Labeling. Immediately after capping, the bottles are sent to labeling machines, where each bottle is affixed with a label. The machines carefully position the labels to ensure a neat and polished appearance for the product. One of the most critical stages is quality control during ketchup production. Throughout the conveyor line process, automated quality control systems are in place. Sensors and cameras inspect the fill level of the bottles, the tightness of the caps, and the accuracy of the labeling. If a defective bottle is found, it is automatically removed from the conveyor line. To ensure a long shelf life for ketchup, the bottles undergo a final sterilization process after packaging. First, the bottles of ketchup are placed in autoclaves, where high temperatures and pressure are applied to complete the sterilization of the product. This process eliminates any remaining microorganisms that may have survived pasteurization, ensuring the product's safety without the need for preservatives. After the heat treatment, the bottles are cooled to room temperature. This process is also automated and carefully monitored to prevent any thermal damage to the bottles. I should also mention the benefits of ketchup for those looking to lose weight, as 3.5 ounces of the sauce contain only 112 calories. Once all stages of production are complete, Heinz ketchup is prepared for shipment to warehouses and retail locations. The finished ketchup bottles are transported from the production line to the warehouse using automated systems. At the warehouse, the products are sorted by batches and expiration dates. Special pallet systems are used to store the bottles at controlled temperatures to prevent any damage or loss of quality during storage. Heinz also has a well-organized logistics system that ensures product distribution worldwide. This process relies on modern automated tracking systems to monitor the movement of goods. The products are distributed through distribution centers and delivered to stores, supermarkets, and specialized retail locations. Strict transportation conditions are maintained to preserve the quality of the ketchup during transit. As I mentioned before, quality control is an integral part of every stage of Heinz ketchup production. Every step, from selecting the tomatoes to packaging, is monitored using advanced technologies and automated systems. The key quality control measures include laboratory analysis of ingredients, temperature monitoring, and inspection of the finished product. Every ingredient that enters the production process is tested to meet safety and quality standards. During heat treatment, the temperature is constantly monitored to ensure product safety and preserve its flavor. After pasteurization and sterilization, the finished ketchup undergoes further testing to ensure it meets quality standards, including checks for thickness, color, taste, and consistency. The Heinz logo adorns every third bottle of ketchup worldwide, and in the United States, it's on every second bottle. Heinz is one of the foremost recognized food brands globally. Each year, Heinz sells 11 billion bottles, which is roughly 2 bottles for every person on Earth. Founded in 1869, the company has remained at the forefront of the food industry by constantly evolving and maintaining high-quality standards. Just think about it, 155 years on the market. An impressive figure, right? Heinz operates 74 factories worldwide and distributes its products in more than 200 countries. They were also among the first to expand internationally, and today they hold around 30% of the global ketchup market. In fact, Heinz is considered a pioneer in many production trends. They increased the number of bottles produced per worker from 350 to 3,500. Heinz was also the first to introduce cleanliness in production. Before that, it's hard to imagine the unsanitary conditions where food was made. Additionally, they significantly reduced the use of preservatives in their products. The Heinz family tirelessly worked on automating their factories and created a real assembly line long before Henry Ford. The company has also received numerous medals and awards for advertising their products. Moreover, Heinz had to defend their original bottle designs in court to protect their unique shape for ketchup bottles. Have you ever wondered how millions of cans of Monster Energy are produced, providing a daily energy boost to millions of people around the world? Today, I'm taking you behind the scenes at one of the largest factories in the United States, where this iconic drink is made. Get ready to witness the incredible scale of production and some truly fascinating details. When I arrived at the Monster Energy factory, the first thing that struck me was its sheer size. This isn't just a building, it's an entire world with a life of its own, where thousands of gallons of the famous energy drink are produced every day. Let me walk you through all the behind-the-scenes details that go into every can sitting on a supermarket shelf. The preparation of water is the first and most crucial stage in Monster Energy production. At the factory, the water goes through several purification steps, starting with coarse mechanical filtration and ending with reverse osmosis. Ultraviolet treatment and activated carbon are also used to remove any possible contaminants. The result is water of the highest quality, comparable to that used in the medical industry. This step is so critical that each batch of water undergoes rigorous multi-level testing in the lab to ensure its purity and compliance with strict quality standards. The factory uses state-of-the-art filtration systems that can remove even the tiniest particles, ensuring the water is perfect for use in the production process. Next comes the preparation of ingredients. Key components like taurine, caffeine, glucuronolactone, B vitamins, and sugar are carefully measured and mixed in precise proportions to create Monster Energy's signature taste. Special attention is given to the quality of each ingredient. For instance, caffeine arrives at the factory in pure powder form, undergoing strict quality control. Lab experts conduct thorough analyses of each batch of ingredients to ensure they meet the required standards. It's important to understand that each of these components plays a crucial role in delivering the energy and alertness that every Monster Energy drinker feels. Every ingredient is meticulously selected to maximize both effectiveness and consumer safety. The mixing takes place in enormous stainless steel tanks that hold up to 100,000 liters. In these tanks, all the ingredients are combined with the purified water, and the process of creating the drink begins. Special blade mixers ensure the even distribution of all substances, so that the flavor is consistent in every can. Once mixing is complete, samples are taken and sent to the lab for analysis. Everything is tested here, from sugar content to acidity levels and the correct balance of vitamins. Quality control at this stage is critical, as even the slightest variation in proportions could affect the final taste and quality of the drink. Once the drink is ready, it moves to the carbonation line, one of the most fascinating stages. Carbon dioxide is added to the liquid, giving the beverage its signature fizz. The level of carbonation is carefully controlled to ensure the perfect taste and mouthfeel when consumed. The carbonation process happens in several stages, allowing the optimal amount of carbon dioxide to dissolve into the liquid, delivering that fresh and energizing flavor. Every tank of the drink is tested to ensure that the carbonation levels meet the standards set for Monster Energy products. The next stage is filling the beverage into cans. The production line at the Monster Energy factory is a true marvel of modern engineering. The cans, made from aluminum, go through a pre-cleaning process before being filled. The cans are then filled under pressure to prevent the loss of carbon dioxide. The speed of the filling process is impressive. In 1 minute, the line can fill and seal up to 1,200 cans. After filling, each can is sealed with a lid and undergoes a leak test using advanced technology, including X-ray scanning. At this stage, a visual inspection is also carried out to ensure that each can meets external quality standards. There are no dents, scratches, or other defects that could affect the product's appearance. Once filled, the cans move on to the pasteurization stage. In specialized equipment, the cans are heated to a specific temperature, which helps eliminate potential microorganisms and extend the product's shelf life. Pasteurization is carefully controlled to preserve the drink's beneficial properties and flavor without compromising quality. The pasteurization technology is tailored to the characteristics of the energy drink to maintain its bold taste and freshness. The entire process is monitored by automated systems, ensuring consistent product quality throughout production. After pasteurization, the cans move on to the labeling and packaging stage. Here, each can is adorned with Monster Energy's bold and recognizable label. This process happens at incredible speed, Specialized machines can apply up to 60 labels per second. Once labeled, the cans are grouped together and packed into boxes, with each box holding 24 cans. The boxes are then stacked onto pallets and sent to the warehouse. The label is not just for decoration, it is the product's signature that grabs consumers' attention. At the factory, great care is taken to ensure the quality of both the printing and the attachment of the labels, so every can looks flawless. The factory's warehouse is a fully automated logistics center. Robotic arms carefully stack the pallets and automated forklifts transport them to trucks. Each day, over 500,000 cans of Monster Energy are shipped from the warehouse, ready to be distributed across the country and internationally. The logistics are meticulously planned to ensure timely delivery of the product to any location in the world. The warehouse also maintains a strict inventory system, allowing for the tracking of every batch of products and ensuring quality is maintained throughout all stages of transportation. At the factory, special attention is given to product quality. Every stage of production is accompanied by strict quality control measures. The facility has its own laboratory, where hundreds of tests are conducted daily, from ingredient quality checks to analysis of the final product. Specialists not only monitor taste, but also the level of carbonation, the integrity of the can seals, and the overall appearance of the product. The laboratory is equipped with state-of-the-art instruments that allow precise analysis of the product's composition, ensuring its safety and compliance with standards. For instance, gas chromatography is used to measure the level of carbon dioxide, while spectrophotometry is employed to verify vitamin content. Additionally, the Monster Energy factory is actively working to reduce its environmental impact. Energy-saving technologies are utilized, and production waste is recycled. For example, aluminum cans that fail quality control are sent for recycling and reused, helping to reduce waste and lessen the factory's ecological footprint. The plant also collaborates with local authorities and environmental organizations to minimize carbon dioxide emissions and incorporate renewable energy sources into production. One example of these initiatives is the installation of solar panels on the roofs of the production buildings, which provide a portion of the factory's energy needs. Have you ever wondered how the microchips that power modern technology and artificial intelligence are made? No, they don't fall from the sky or grow like mushrooms in the forest. They are the result of incredibly complex processes that demand extreme precision and automation. Let's dive into the world where pure silicon becomes the brains of our devices and discover just how much effort goes into making it possible for you to ask an artificial intelligence, "How do I talk to a girl?" The primary material used to manufacture chips is pure silicon. The choice of this material is no coincidence. Silicon has semiconductor properties that allow it to efficiently conduct electric current under certain conditions, which is essential for creating microchips. But silicon crystals don't just appear out of thin air, they are grown. Like mushrooms, can you imagine? Specialized companies are responsible for growing silicon, providing the semiconductor materials needed to produce microchips. The main suppliers are Japanese, Taiwanese, German, and American companies. Silicon monocrystals are formed using the Czochralski method, where silicon is melted and then gradually cooled to form a large cylindrical ingot. In a high-temperature furnace, a seed crystal, also called a seed, is slowly pulled from the molten silicon while rotating. This ingot is then sliced into thin silicon wafers, usually between 200 and 300 microns thick. These silicon wafers are polished to a perfect smoothness and cleaned of any contaminants to prevent defects in the future microchips. This is done using special chemical solutions and mechanical procedures. Next, chip designers create the architecture, which includes millions of transistors, logic gates, and other components necessary to perform artificial intelligence tasks. This is an incredibly complex process, requiring a high level of specialization and the use of automated design software. First, they design the chip's architecture, the structure and layout of all the components. The architecture of an artificial intelligence chip may include graphics processing units, neural network processors, and specialized computing blocks designed for high-efficiency matrix operations. During the design verification phase, computer simulations are used to test and validate the design. This allows for the identification and correction of errors before moving on to physical production. The next stage in chip production is called photolithography. Photolithography is a crucial technology for manufacturing microchips, involving the creation of the pattern for future electrical circuits on a silicon wafer using light. This is one of the most critical steps because it determines the precision and density of the components on the chip. A specialized robotic machine, equipped with tweezers to avoid direct contact and prevent contamination, handles the silicon wafer. The machine then immerses the wafer in chemical baths with cleaning solutions to remove any dust particles, oils, or other impurities. Afterward, the wafer is placed on a machine that spins it at high speeds to evenly distribute a layer of light-sensitive material across its surface. It's similar to placing the wafer on a fast-spinning disc and dropping liquid on top, allowing the material to spread out through the spinning motion. To apply the pattern onto the wafer, a process called light exposure is used. A machine, similar to a large projector, uses a photomask, essentially a template that allows light to pass through in specific areas. This projector directs ultraviolet light through the photomask, and the light reaches the photoresist only in certain spots. It's like using a stencil for painting, where the paint only goes through the cutout areas. After exposure, the wafer is again immersed in a chemical solution, but this time to develop the image. The solution dissolves the parts of the photoresist that were exposed to the light, or the parts that were not, depending on the type of photoresist. Think of it as developing a photograph, where the details of the pattern emerge in the chemical bath. Once the image is developed, the wafer moves to another machine for the etching process. This is similar to carving and is called etching. The machine either sprays gas plasma onto the wafer, dry etching, or immerses it in a chemical solution, wet etching, to remove the unwanted material, leaving only the necessary parts behind. In the final stage, the wafer is cleaned again to remove any remaining photoresist. Machines immerse the wafer in chemical solutions or use special laser technologies to ensure it's thoroughly cleaned. Can you imagine how much micro-level work goes into all of this, just so my friends can ask artificial intelligence how to approach a girl? Or, get this, I overheard some girls asking ChatGPT to do tarot card readings for them. So, here we have people and machines working hard, meticulously developing technologies, and then someone's like, pull a card of the day for me. Admit it, do you get asked to do that kind of crazy stuff often? Anyway, let's continue. After the remaining photoresist is removed, the silicon wafer undergoes a visual inspection using microscopes, but it's all done by automated systems, robots and cameras scanning for even the tiniest defects to ensure everything is flawless. At every stage, nearly everything is handled by automated machines, because even the smallest mistake or speck of dust can damage the microchips. Humans mainly monitor the process, adjusting machine settings and troubleshooting if any issues arise. To create regions on the wafer with different electrical properties, a process called ion implantation is used. This involves introducing impurities into the silicon. Ions of a specific material are accelerated and embedded into the silicon wafer, altering its semiconductor characteristics. After implantation, the wafer undergoes a process called annealing, heating the wafer to activate the ions and restore the crystal structure of the silicon. Next, layers of metal, typically aluminum or copper, are applied to form electrical connections between the transistors and other components of the chip. After manufacturing is complete, each chip undergoes a thorough inspection for defects and a series of tests to confirm its performance. The testing includes checks for functionality, speed, heat resistance, and energy consumption. Chips that do not meet quality standards are either discarded or recycled. This process ensures that only products fully meeting all technical specifications are retained. Packaging chips is the final stage of production, where the finished chips are prepared for use in electronic devices. This process is also primarily carried out by automated machines. First, the silicon wafer, which contains hundreds or even thousands of chips, needs to be cut into individual chips. A special laser machine, or a precision diamond cutter, is used to slice the wafer into separate tiny chips. This process is called dicing. Once the wafer is cut, each chip is attached to a substrate, base, which helps connect it to the rest of the electronics. An automatic die attach machine picks up each chip and precisely places it on the substrate, using a special adhesive or other material to secure it in place. For the chip to interact with other components, it needs to be connected to the substrate with very thin wires. This is done using a wire bonding machine, which welds fine gold or aluminum wires that link the chip to the contacts on the substrate. After the chips are connected, they must be protected from mechanical damage, dust, moisture, and other harmful elements. To achieve this, the chips are enclosed in protective casings. An automatic chip packaging machine covers the chip with a special plastic or epoxy resin. This process involves encapsulating the chip in a protective material, creating a durable casing around it. After testing, the chips are marked with information such as the model, serial number, and other relevant data. This is done using laser marking machines, which quickly and accurately apply all necessary information to the surface of the chip's casing. Once testing and marking are complete, the chips are packed into anti-static boxes or specialized plastic tapes for easy transportation. Automated packing machines organize the chips in rows, package them in special containers, and prepare them for shipment to customers. The chips are inspected to ensure they meet all standards and are ready for transport. This process is overseen by logistics personnel and automated systems, which manage the warehouse, sort the products, and handle shipping to clients. Did you know that the world's largest mozzarella producer uses 5 million pounds of milk every day? This massive operation ensures that every drop of milk undergoes strict quality control. In this video, we reveal the secrets behind this enormous production process, where mozzarella is stretched to the perfect texture through machinery worth millions of dollars. Want to see how ordinary milk transforms into a true cheesy masterpiece? Don't miss a single second. Milk is the primary ingredient for producing mozzarella. Leprino Foods partners with local farmers and dairy cooperatives who supply fresh milk in optimal volumes. To ensure consistent quality, the company sources milk primarily from regions close to its production facilities. This minimizes transportation time and preserves the milk's freshness. Suppliers go through a rigorous selection and monitoring process, as every batch of milk must meet Leprino Foods quality standards. Each shipment is tested for contaminants, bacterial levels, and key factors like fat and protein content, which are essential for mozzarella production. Any milk that doesn't meet quality standards is rejected. Milk is delivered to the plant in large refrigerated tankers that keep it at low temperatures to maintain freshness. Once the tankers arrive, they connect to the milk intake system, which pumps the milk into large storage tanks. These cooled tanks hold the milk at around 39 degrees Fahrenheit to prevent spoilage until it's ready for pasteurization. Each tank, capable of holding thousands of gallons, is monitored by automatic temperature control systems. From these tanks, the milk is automatically transferred to pasteurization units, requiring no manual handling, as pumps and pipelines ensure its safe transport. At large production facilities, pasteurizers are directly linked to the storage tanks to minimize the risk of microbial contamination. Inside the pasteurization unit, the milk is heated for 15 seconds in a standard high-temperature, short-time pasteurization process. This takes place in a heat exchanger, where the milk flows through a series of tubes surrounded by hot water or steam. After this brief heating, the milk is quickly cooled back to its original temperature in the same heat exchanger. Here, hot milk encounters cold water without mixing, which helps retain its freshness and nutritional quality. A key step in mozzarella production is the coagulation process, or curdling of the milk, which creates the foundation for the cheese. To achieve this, milk is combined with rennet, an enzyme that helps form curds. Additionally, bacterial cultures may be added to promote milk acidification, laying the groundwork for the cheese's flavor profile. After pasteurization, the milk is automatically transferred to cheese-making vats, large stainless steel tanks with smooth interiors for easy cleaning and sterilization. Once the milk is in the vats, an automated system adds rennet and bacterial cultures. These vats are equipped with automatic mixers or paddles that gently and evenly distribute the enzyme through the milk. Temperature control systems maintain the milk at an ideal temperature to support proper coagulation. After adding the rennet, the mixing stops and the milk rests for 30 to 40 minutes. During this time, the enzyme converts the milk protein, casein, into a dense mass of curds, the cheese base. I have to say, the smell at this stage is quite unique. It's intensely sour, almost hard to believe this will eventually become something edible. But as the process continues, the appearance improves, and the aroma turns more appetizing. The next step is whey separation. The cheese base is heated, which makes the curd denser and helps release the liquid faster. This whey is collected for further processing or repurposing into other dairy products. Now it's time to stretch the cheese. Yes, you heard that right. This is the key step in mozzarella production. At this stage, it actually has a rubbery texture. Traditionally, this stretching was done by hand, but at Leprino Foods, the process is fully mechanized. The cheese is placed in a specialized stretching machine, where it is continuously mixed and pulled by paddles or screw mechanisms that carefully stretch and fold it. The machine rotates slowly, giving the cheese a stretchy consistency without breaking down its structure. The screw mechanisms turn in different directions, which helps evenly distribute the proteins and gives the cheese a smooth texture. During the stretching process, cooled air is added to gradually stabilize the cheese and prevent overheating. This cooling step is also essential for achieving the perfect mozzarella texture. Stretching stops automatically when sensors indicate the right consistency. At this point, the cheese takes on an elastic structure and can be easily shaped into the desired form. Cheese can be shaped into various forms, like balls, blocks, and cubes on automated production lines. Let's look at the different processes. To make cheese balls, the cheese is fed into a specialized machine, where it is rolled between rotating discs or paddles that portion it into small sections and shape it into balls. The machine can adjust the size of the balls to create the desired dimensions, from tiny pearls to larger balls suitable for salads and appetizers. For larger cheese blocks, stretched cheese is placed in special rectangular molds. Within these molds, the cheese is compressed and then cooled to help it retain its shape. After cooling, the blocks are cut to specific sizes and packaged. To produce cheese cubes, the cheese is first formed into larger blocks, which are then sliced into small, uniform cubes by automated cutting machines. For stick or strip-shaped cheese, a large block is initially sliced into strips using specialized blades, after which the strips are packaged. These cheese sticks are convenient for snacks or appetizers. Next, we move on to salting mozzarella. This step impacts not only the flavor of the cheese, but also its texture and shelf life. First, a special brine solution is prepared, a concentrated mixture of water and salt at a specific concentration, maintained at a low temperature to prevent the cheese from softening. The solution is carefully stirred to ensure the salt dissolves evenly, creating a stable level of concentration. Depending on the shape, whether balls, blocks, or sticks, the cheese is transferred to the brining baths on a conveyor belt or in special containers. It is important for the cheese to be fully formed and stabilized before salting. Otherwise, it may lose its shape. The cheese is immersed in the brine solution in specialized brining tanks. These tanks may include a gentle mixing system to ensure that each piece of cheese is evenly coated by the solution. Salting takes between 15 and 30 minutes, depending on the size of the pieces, allowing the salt to penetrate the outer layers and give the cheese a mild, salty taste. Maintaining a consistent salt concentration and temperature in the bath is crucial to ensure quality salting. Automated control systems monitor the salt levels in the water and add salt as needed. Temperature is also regulated to prevent the cheese from softening or drying out excessively. Once the salting process is complete, the cheese is removed from the solution via conveyors and carefully dried. This is done on special racks that allow excess brine to drain off, or with gentle airflows that softly dry the surface of the cheese. After cooling and salting, the cheese is transferred to the packaging line on a conveyor belt. These may be mozzarella balls, cubes, sticks, or blocks, each moving toward different packaging stations based on their shape. Near the line, a machine supplies the packaging materials. These could be plastic bags, containers, or vacuum-sealed pouches. The machine automatically unwinds the packaging material, prepares it for filling, and ensures each package is clean. When the cheese reaches the packaging station, a specialized dispenser automatically places the correct amount of cheese into each package. The machine measures portions with high precision to ensure that all packages have the same weight and appearance. Once the cheese is in the bag or container, the packaging machine seals it. This might be vacuum sealing, where air is removed from the package for optimal storage, or heat sealing, where the top of the package is heated and tightly welded to create an airtight seal. After sealing, the packages pass through a special printer that automatically prints labels with product information, such as the production date, expiration date, and sometimes a barcode. Have you ever wondered why you can enjoy fresh strawberries, even when they're out of season? It's not just luck. It's the result of complex processes and technologies that remain hidden from the consumer's view. Today, I'll take you behind the scenes of modern factories where fruits are frozen, dried, and canned, ensuring you always have access to a healthy snack. Buckle up, it's going to be fascinating. Strawberries intended for freezing are usually harvested at the peak of ripeness, when they're at their sweetest and juiciest. Why strawberries, you ask? Because they're the most popular frozen berry in the United States. The country grows an impressive 1.5 million tons of them each year. The US is one of the world's largest strawberry producers, with California leading the way, accounting for over 90% of the nation's total output. Harvesting typically takes place early in the morning, while the berries are still cool and less prone to damage. On large farms, specialized harvesting machines are often used to carefully cut the strawberries. However, for processing, a significant amount of strawberries are still picked by hand. That's because machines can't always handle delicate fruits without causing damage. Hand picking is more precise, allowing workers to select only the perfectly ripe berries that are ideal for freezing or further processing. Once harvested, the strawberries are sent to the factory. First, the strawberries are sorted to remove leaves, stems, and any damaged berries. Next, they're placed in specialized washing tanks. The berries are either submerged in large containers of clean water or, more commonly, rinsed with powerful streams of water to wash away dust, dirt, and any residual chemicals. Occasionally, weak solutions, such as those containing hydrogen peroxide or organic acids, are used to help eliminate bacteria and reduce the risk of spoilage. These solutions are completely safe and leave no harmful residue. After the antiseptic treatment, the strawberries are rinsed again with clean water to remove any remaining solution. They are then dried to remove excess moisture, either by using fans or simply by draining off the water. According to statistics, the average American consumes about 7 to 9 pounds of strawberries per year. Personally, though, I go through that much in a month. How about you? Freezing is the most critical step, as it determines whether the berries will retain their flavor, texture, and nutritional value. Typically, the method used is flash freezing. Strawberries are laid out in a single layer on conveyor belts and pass through rapid freezing tunnels. These tunnels maintain a temperature of around -104 degrees Fahrenheit or even lower. This process causes the water inside the berries to freeze instantly, forming extremely small ice crystals that do not damage the fruit cells. To ensure each strawberry stays intact and doesn't stick to the others, the conveyor vibrates continuously. This method preserves the strawberry structure and minimizes juice loss during thawing. Compared to slow freezing, which forms larger ice crystals, flash freezing delivers the highest product quality. About 30% of strawberries in the United States are frozen for use in products consumed year-round. This practice is popular for both export and domestic use. A major advantage is that frozen strawberries can be stored for up to 12 months without losing their taste or nutritional benefits. Drying strawberries has become an increasingly popular method of preservation. Dried strawberries are enjoyed as a healthy snack and are often added to oatmeal, yogurt, baked goods, granola, and trail mixes. Another trendy option is strawberry chips, which have a light, crisp texture while retaining their vibrant flavor. Strawberries can be dried whole or sliced into thin pieces, which dry faster and make perfect chips. Sliced strawberries are convenient for quick snacking, while whole berries are better suited for use in recipes. The drying process involves placing the strawberries in specialized chambers, where warm air circulates to gradually evaporate the moisture. This slow drying helps preserve their aroma and flavor. Another method involves freeze drying, where frozen strawberries are placed in a vacuum chamber. Under low pressure, the water in the berries sublimates, turning directly from ice to vapor. This results in lightweight, crispy, freeze-dried strawberries that retain their color, shape, and nearly all their nutrients. Though freeze-drying is one of the most expensive methods, it offers the highest quality. I have to admit, after this journey, I couldn't resist buying a home dehydrator to make my own strawberry chips and more. So, while editing this video, I've got a bowl of crunchy, nutritious dried strawberries right next to me. The perfect healthy snack. They're great for on-the-go munching or packing in kids' lunchboxes. To make strawberry jam, ripe, juicy berries are used to ensure the jam is flavorful and rich. After washing, the green tops and calyxes are removed, with care taken to preserve the shape of the berries. This is done either by hand or with specialized tools to minimize the loss of pulp. In production, the strawberries are processed to achieve the desired consistency. This could range from a light chopping into pieces to a more thorough blending for a smooth, uniform jam. This step is carried out quickly using specialized cutters or presses. The strawberries are then typically mixed with sugar and pectin in large industrial mixers. Pectin is almost always added, as it ensures a stable jam texture and helps control thickness, which is crucial for large-scale production. To balance the acidity, citric acid or natural juice concentrate is also added. The prepared mixture is heated in large cooking kettles with precise temperature and time controls. As the strawberries cook, the mixture gradually thickens and the jam develops its desired texture. The high temperature also helps eliminate any potential microorganisms. Once the jam is ready, it's tested for consistency, color, flavor, and aroma. Automated devices are used at this stage to measure density and sugar levels, ensuring the product meets quality standards. The finished jam is then automatically poured into sterile jars or containers, which are sealed airtight to preserve freshness. The process of making strawberry puree is equally fascinating. The prepared berries are placed in grinders, where they are processed into a liquid state. This is achieved using specialized mills or blenders that quickly break down the fruit into a smooth, uniform texture. The pureed mixture is then passed through special sieves or filters to remove seeds and small bits of skin, ensuring a silky smooth puree if a very fine consistency is desired. This step is crucial for producing a product suitable for baby food, desserts, or yogurts, where a soft texture is important. To extend its shelf life, the strawberry puree undergoes pasteurization, a process in which it is heated to a specific temperature that destroys harmful microorganisms while preserving the fruit's flavor and color. Pasteurization typically takes place in tubular heaters or specialized cooking systems. In some cases, especially when the puree is intended for industrial use, such as in confectionery or for making semi-finished products, it may be frozen. To produce juice, strawberries are first processed into puree using industrial blenders or mills. This step creates a mass from which juice can be more easily extracted. The strawberry puree is then sent to specialized hydraulic or belt presses, which separate the juice from the pulp. This method ensures maximum juice yield, leaving minimal residue such as skin and seeds. The extracted juice is filtered to remove solid particles, resulting in a smooth, uniform liquid. To extend its shelf life, the strawberry juice undergoes pasteurization, a process that involves rapid heating followed by cooling. The finished juice is then poured into sterile bottles or cartons, sealed tightly, and stored for later use. The same processing principles apply to other fruits and berries. When it comes to nutritional benefits, freezing preserves most vitamins, including vitamin C and antioxidants. Additionally, like fresh berries, frozen strawberries are low in calories, making them an excellent dessert option for athletes and those focused on healthy eating. What's your favorite fruit or berry? Let me know, and maybe my next video will feature it. Two brothers, one factory, and a feud that forever changed their destinies. But how did Adidas rise to the pinnacle of global sports? In this video, we'll uncover the fascinating story of a brand that began by producing military clothing and shoes from old tires. From the era of Nazism to Olympic records, from corporate rivalries to fashion revolutions, discover how Adidas sneakers transformed from a family business into a global empire that reshaped the history of sports. The idea for the Dassler family's venture into shoemaking was inspired by the First World War. In 1920, during a family meeting, they decided to start making shoes. This marked the beginning of a story that would eventually change the face of global sports. In the small town of Herzogenaurach, the Dasslers crafted orthopedic shoes for training war-disabled athletes returning from the front, as well as comfortable slippers for everyday use. Adolf Dassler, a calm and diligent worker, came up with the idea of making the upper part of the shoes from surplus military uniforms, while using old car tires for the soles. His older brother, Rudolf, who was more outgoing and an excellent salesman, handled the business side of things. On July 1st, 1924, the two brothers officially founded their company, calling it the Dassler Brothers Shoe Factory. Things were clearly going well for the two German brothers. Just a year after founding their factory, Adolf came up with the idea to create the first soccer cleats with studs. The studs themselves were crafted by two blacksmith brothers named Zelin. This soccer model, along with gymnastic slippers, became the core products of the Dassler factory. 2 years later, Adolf and Rudolf rented an entire building for their growing operation and hired as many as 25 employees. They were soon producing 100 pairs of shoes a day and eventually bought the building outright. In 1928, the brothers, together with a certain Josef Weitzer, improved the design of the studded cleats and secured a patent from the German Patent Office. That same year, the Summer Olympics were held in Amsterdam, where several athletes competed wearing Dassler shoes. Fame came knocking on the brothers' door. In 1929, the Dassler brothers improved their products, particularly their soccer cleats. They focused on refining the design, enhancing the quality of the studs, and adapting their shoes for professional sports. During this time, their footwear gained widespread use among soccer players, boosting the factory's popularity. 2 years later, Germany was hit by an economic crisis. However, this did not affect the Dassler brothers' operations. On the contrary, they began construction on the Villa, a 3-story building. Over time, the villa served not only as a home for their families, but also as a place to discuss business matters. The brothers and their families lived together in this house, which was conveniently located next to their factory. This made it easier to manage production and grow their business. However, living under one roof also led to many challenges for the families. Despite sharing a home, tensions between the two households began to surface. The kitchen was shared, and meals were prepared for both families, but their tastes and preferences often diverged. Rumor had it that there was even a silent competition over whose dining table looked more lavish. Meanwhile, the villa became a symbol of the rapid growth and success of the Gebrüder Dassler Brothers factory. By this time, the brothers' footwear was already well known among athletes. In 1932, sprinter Arthur Jonath took 3rd place in the 100-meter race, wearing Dassler shoes, of course. Fame entered the Dassler household and firmly established itself there. In 1936, Jesse Owens, also sporting Dassler shoes, set 5 world records and won 4 gold medals. The brothers struck gold as well, with factory sales soaring to over 400,000 marks. Just 2 years later, they opened another factory in their hometown. The outbreak of World War II in 1939 marked a turning point for the brothers and their business. Most private enterprises were forced to adapt to meet wartime demands, and the Dassler factory was no exception. Instead of producing athletic footwear, the factory shifted to making shoes for German soldiers. There were also attempts to manufacture components for anti-tank rocket launchers, but the equipment proved inadequate for such a conversion. Both brothers were drafted into the military, although the younger brother, Adolf, was soon recalled to produce training shoes for soldiers. Both brothers were members of the National Socialist Party, which was a common occurrence in Germany at the time. Although there are suggestions that their membership was purely formal, it left a lasting impact on the subsequent reputation of their brands. In 1945, the town where the Dasslers lived fell under the American zone of occupation. Rudolf was sent to a prisoner of war camp, while Adolf stayed behind and began supplying hockey skates to the United States. Quite an unexpected career twist, wouldn't you say? Initially, the Americans intended to demolish the factory, but Adolf managed to convince them that it was solely producing footwear. In exchange for the skates, the factory received surplus US military supplies, including tents, baseball gloves, and similar items. By the end of the occupation in 1946, the factory was in a dire state. Rudolf eventually returned home, and the brothers resumed their original craft, making shoes from leftover military materials. The 47 employees hired at the time were paid not in cash, but in firewood, yarn, and other essential goods. The tough times ultimately drove a permanent wedge between the Dassler brothers. After their father's death, their relationship completely unraveled. The exact cause of their falling out remains unclear. Some speculate it was due to differing views on Nazism. Others suggest Rudolf harbored resentment, believing Adolf could have secured his release from captivity, but chose not to. It's also possible they simply couldn't divide their inheritance amicably. While the precise reason is unknown, the rift grew so severe that they decided to split the business. This marked the end of their collaboration, but the beginning of two legendary brands. Adolf stayed at the family home, known as the Villa, which was conveniently located near his new factory, the foundation of what would become Adidas. Indeed, Adolf established Adidas based on the old factory. The brothers agreed not to use their company's original name and divided the facilities. Adolf's firm was initially called Adas before evolving into Adidas, with Adi from his first name and Das from their last name. The iconic three stripes became Adidas's symbol. He simply added an extra stripe to the old logo. Adolf actively collaborated with athletes, particularly soccer teams, which helped the brand quickly rise to prominence in the sports world. Meanwhile, Rudolf named his share of the business Ruda, combining parts of his first and last names. However, he later rebranded it as Puma, which remains a major brand to this day. If you'd like a video detailing the growth of Rudolf's factory, feel free to let me know in the comments. After patenting an updated logo and name, Adolf created the first soccer cleats with removable rubber studs. The following year, he improved the footwear for playing soccer in adverse conditions, such as on snow or frozen ground. In 1952, Adidas began producing other items in addition to footwear. Initially, these included sports bags, followed by tracksuits made in collaboration with the owner of a textile factory. That same year, runner Emil Zadopek won 3 gold medals at the Olympic Games wearing Adidas shoes, marking a new milestone in the brand's evolution. 2 years later, the German national soccer team, outfitted in Adidas gear, won the World Cup. It was a sensation. Adolf's company signed a series of partnership agreements, solidifying its position in the global market. By 1961, Adidas had fully streamlined the production and distribution of textiles. 2 years later, the brand began manufacturing soccer balls. Shortly thereafter, Adidas introduced the world's first footwear with a molded polyurethane sole. In 1975, Adolf Dassler, with a remarkable legacy behind him, was named an honorary member of the American Sporting Goods Association. 3 years later, the legendary German passed away, and Adidas came under the leadership of his widow, Käthe Dassler. 4 years after that, she also passed away, leaving the company to their son, Horst Dassler. Horst carried on his father's legacy with distinction, even implementing improvements and reforms in the production process. However, tragedy struck again. 6 years later, Horst passed away, and ownership of Adidas fell to his sisters. The Dassler sisters quickly realized they couldn't manage Adidas on their own, so they sold 80% of the company's shares to Bernhard Tapie, the owner of the French soccer club Olympique de Marseille. Under his leadership, the company declined, and Bernard eventually sold the controlling stake to Robert Louis Dreyfus. Louis Dreyfus shifted production to China and several other countries in East Asia. The strategy of using low-cost labor paid off, and Adidas once again became a strong competitor in the sports goods market. The brand also established its own network of flagship stores, achieving unprecedented sales growth in 1996. The company's upward trajectory has continued ever since. Do you think you know everything about Dr. Pepper? What if I told you that the secret recipe for this legendary drink is kept in 2 separate bank vaults, and the owners of those vaults never meet? Or that a single bottle once sold for $7,000? I visited the Dr. Pepper factory, and am ready to reveal secrets the company has been guarding for 140 years. Want to find out what happens if you open a bottle in space? Or how they produce 1,200 bottles per minute? Then this video is for you. Watch until the end. The foundation of Dr. Pepper lies in a unique blend of flavors. Officially, there are 23 of them. Exactly what goes into the mix is a closely guarded secret. What we do know is that the drink combines fruity, vanilla, spicy, and caramel notes. Fans have tried to crack the code, speculating that the flavors might include cherry, almond, vanilla, cinnamon, caramel, chocolate, and even a hint of clove. Interestingly, throughout its entire existence, the drink has remained virtually unchanged, and any attempts to replicate it have ended in failure. Rumor has it that the formula is stored in 2 separate bank vaults in the United States. These vaults are owned by different individuals who never meet, ensuring the recipe remains a mystery. The process begins with creating the concentrate, a complex combination of natural and artificial flavorings mixed in precise proportions. There's even a popular legend at the production facility that the recipe is divided into 2 parts, with each half known only to a separate group within the company. This spy story only adds to the intrigue. To put things in perspective, Dr. Pepper has been on the market for over 120 years, and more than 3 billion liters of it are sold worldwide annually. That's more than the total amount of water in 12,000 Olympic-sized swimming pools. The main component of any soda is water, and Dr. Pepper is no exception. Before being used in production, the water undergoes a meticulous purification process consisting of multiple stages. The first stage is filtration, which removes all mechanical impurities. I've been making videos like this for a while, and I'm still amazed at how much unexpected stuff can be found in ordinary water. The second stage is disinfection, ensuring the water is completely safe for consumption. Finally, there's composition adjustment, which creates the perfect balance of minerals that influence the flavor of the drink. Clean, high-quality water is essential to maintaining Dr. Pepper's iconic taste around the world. Can you believe that the water purified at Dr. Pepper facilities is held to a standard higher than regular drinking water? That's how they ensure every bottle has the same recognizable flavor no matter where it's enjoyed. After the water is prepared, the concentrate is added. The mixing process takes place in special stainless steel tanks that ensure sterility and uniformity of the mixture. The proportions are carefully controlled by automated systems, as water makes up about 90% of the drink's total volume. This part really amused me. Turns out, we're not just drinking a concoction of random chemicals. The concentrate is added in precise amounts to ensure the flavor is spot on. At this stage, sugar or its substitutes are also added, depending on the product type. There's the regular version and the diet version of the drink, but I'll cover that later. The sugar is first dissolved in hot water to form a syrup that blends easily with the other components. The famous reaction between Mentos and soda becomes even more exciting with Dr. Pepper thanks to its rich, syrupy composition. The fountains it creates are taller than with cola. I haven't tried it yet, but I definitely will. Meanwhile, Dr. Pepper can also be frozen and turned into a crystalline syrup structure, which chemists love to study. I couldn't resist trying that one. Scientists and hobbyists often use Dr. Pepper for fascinating experiments. The biggest consumers of Dr. Pepper are in the United States, where nearly 80% of all production is consumed. However, in recent years, its popularity has been growing rapidly in Europe and Asia. Dr. Pepper wouldn't be the same without its signature fizz. This bubbly effect is achieved through carbonation, a process where the drink is infused with carbon dioxide gas. Carbonation takes place in specialized equipment. The drink is chilled to about 32 degrees Fahrenheit, as cold liquids retain gas more effectively. Under high pressure, carbon dioxide is injected into the mixture, creating the familiar bubbles. The carbonation process feels like something straight out of a chemistry lab, as the pressure in the system reaches 5 atmospheres, almost twice the pressure in a car tire. Interestingly, if you were to open a bottle of Dr. Pepper in space, the gas wouldn't escape because there's no atmospheric pressure. That means drinking Dr. Pepper in zero gravity is essentially impossible. The finished drink is sent to the bottling line, a fast and highly automated process. First, bottles or cans are sterilized. Then, they are filled with the drink in mere seconds. Next comes the airtight sealing of the caps. The final products are packed into boxes or shrink-wrapped and then sent to warehouses before making their way to stores. Dr. Pepper ensures precise logistics to keep the drink fresh and of the highest quality when it reaches the shelves. Dr. Pepper factories are marvels of modern engineering. I was amazed to learn that they produce 1,200 bottles per minute. That's 20 bottles every second. In a single day, a factory can fill up to 10 million cans and bottles. The entire process, from water purification to packing the drink into boxes, takes less than an hour. Each bottle or can of Dr. Pepper isn't just a container. It's an essential part of the brand. The packaging design changes up to 10 times a year to attract new audiences. During holiday campaigns, limited edition series are released, often becoming collector's items. For example, to celebrate the brand's 125th anniversary, retro-style bottles were introduced. Fun fact: the oldest known bottle of Dr. Pepper, dated to 1891, was discovered at an auction and sold for $7,000. Looks like I've just found a reason to clean out my garage, and maybe my dad's too. It was great to learn that Dr. Pepper is actively implementing environmental initiatives in its production processes. For example, the factory uses bottles made from recycled plastic. Modern plastic bottles weigh 25% less than they did 10 years ago, reducing plastic use by millions of tons. The company is also cutting carbon emissions during transportation. Additionally, the production process conserves water during equipment cleaning. Producing 1 quart of the beverage requires approximately 4 gallons of water, including the cleaning process. This is significantly less than some competitors, and serves as an example of efficient resource use. The company is committed to making its production as green as possible without compromising product quality. To achieve this, management invests in waste collection and recycling projects, particularly in countries with lower levels of environmental awareness. Despite its name, this drink was never created by medical professionals. The name was invented as a marketing ploy to highlight the medicinal benefits of carbonated beverages in the 19th century. Old labels featured clocks showing the times 10 o'clock, 2 o'clock, and 4 o'clock. This was a suggestion to drink the beverage 3 times a day to maintain energy. Let me get back to telling you about the diet version of the drink. In 1962, the world was introduced to Diet Dr. Pepper, the first low-calorie version of the original. Its taste turned out to be so similar to the classic that many fans still cannot tell the difference. Interestingly, producing the diet version requires a special approach, as I mentioned earlier. Instead of sugar, artificial sweeteners are used, which are added during the syrup mixing stage. One of the most popular options today is Dr. Pepper Zero Sugar, which contains absolutely no calories. How do 15,000 gallons of milk turn into butter? Why was it once as valuable as gold? And why do modern artists sculpt masterpieces from it? This process isn't just physics, it's pure magic. Magic that transforms everyday essentials into something indispensable. Ready for a journey that'll change how you see butter forever? Let's dive in. So, our story begins with cows. Picture this: farmers milking cows, and that fresh milk heads to the factory in specialized tanker trucks. One tanker can hold about 15,000 gallons of milk. These trucks are airtight and refrigerated to keep the milk fresh during the journey. Fun fact: demand for organic butter has risen by 13% in the last 5 years as consumers lean towards eco-friendly options. It takes about 19 to 24 quarts of milk to make just 2 pounds of butter. The most expensive butter in the world? It's made from Yakutian cow milk and costs over $200 per kilogram. Surprising, right? Every country has its own butter-making traditions. For example, in Tibet, they use yak milk to make butter, not just for food but also for temple lamps. Now, when the milk arrives at the factory, the first thing it goes through is quality control. It's tested for fat content, protein levels, cleanliness, and even the absence of antibiotics. If everything checks out, it's poured into massive stainless steel tanks where it waits for processing. And now for the magic. Well, technically, it's physics, but let's be honest, it looks magical. The milk is loaded into a separator, a machine spinning at mind-blowing speeds. Think of it as a giant centrifuge that spins the milk to separate the lighter cream from the denser skim milk. In the end, you get two products, cream and skim milk. The cream, that's what we need for butter. And the skim milk? It's used to make other products like yogurt or cheese. Butter was first mentioned over 4,000 years ago in Sumerian cuneiform texts. Back then, it wasn't eaten. It was used as a skin ointment or even in religious rituals. In fact, butter is also mentioned in the Bible. In the book of Genesis, Abraham serves his guests butter from the herd. For the Vikings, butter was so precious they used it as currency. They stored it in huge wooden barrels, and it was even considered a status symbol. Makes you wonder how they kept it from spoiling, right? Fast forward to today, the United States produces about 2 million tons of butter annually, making it one of the largest butter producers in the world. States like California, Wisconsin, and Idaho lead the way with massive dairy farms. The cream is heated in special pasteurizers, like a heat tunnel, where it's quickly brought to 160 degrees Fahrenheit and then cooled again. Why? To kill harmful bacteria while preserving the taste and nutrients. Once cooled, the cream moves to the next stage, the exciting part. Here's where the real action starts. Special machines begin churning the cream. Imagine a giant mixer. At first, the cream thickens, resembling whipped cream used in desserts. Before the 18th century, butter was churned manually using wooden barrels or clay pots. Mechanized churners didn't appear until the 1870s, making butter production much easier. As the churning continues, the fat clumps into small balls, forming butter. The liquid that separates during this process is buttermilk. And no, it's not wasted. It's used in baking or even as a drink. The butter starts to look familiar, but is still just a clump of fats. We're about to change that. Now the butter goes into special machines that knead it. This step makes the butter smooth and creamy. At this point, salt may be added to make salted butter. Fun fact, salted butter lasts longer because the salt acts as a natural preservative. In the US, people consume about 4.5 billion pounds of butter annually. During World War II, butter was in such short supply that margarine and substitutes became popular. But after the war, butter made a comeback thanks to its natural taste. Today, butter sales in the US amount to about $3.7 billion, and this market is expected to keep growing. Finally, the home stretch. The butter is cooled to the right temperature and sent to molding machines. These machines give it the perfect shape, just like the bricks you see in stores. Everything's automated from here. A robot picks up the butter brick, wraps it in foil or paper, and places it on the conveyor belt. Each pack goes through one last quality check to ensure perfection. The finished butter is stored in massive refrigerators, waiting for its journey to supermarkets and eventually to your fridge. The US doesn't just produce butter, it exports it too. This year alone, over 46,000 tons of butter were shipped to countries like Mexico, Canada, and Japan. Butter sales peak during the fall and winter holidays. Think Thanksgiving and Christmas when everyone's baking. During the holiday season, Americans buy about 25% of the entire year's butter supply. In the restaurant industry, butter is indispensable. Restaurants across the US use over 500,000 tons of butter annually. Chains like Starbucks, Panera Bread, and McDonald's rely on butter for their baked goods and dishes. These numbers prove that butter remains a staple in American cuisine, despite the rise of alternatives. The largest butter sculpture in the world? It was made in the US at a festival in Illinois in 2017. It weighed over 2,006 pounds and was used to create a detailed sculpture. That year, the festival theme was farming, so the sculpture depicted a farm scene, cows, farmers, and even farming equipment. Isn't that wasteful, you might think? Not at all. Sculptors use butter that's no longer fit for consumption to avoid food waste. Butter has the perfect texture and density for sculpting. Artists work in refrigerated rooms, kept at 40 degrees Fahrenheit, to prevent the butter from melting. They start with a metal frame for support, then layer the butter and shape it using tools like knives and spatulas. To make the sculptures realistic, they even add tiny details like animal fur or folds in clothing. These sculptures don't last long. After the festival, the butter is either recycled or sent to biogas plants, where it's turned into clean energy. This way, butter art gets a second life, contributing to sustainability. And Illinois isn't alone. Similar butter sculptures are featured at festivals in Iowa, Ohio, and other states. Butter, it's not just food, it's art. A medium for creativity and a true reflection of talent.